right.
That never happens.
I won't get bullied.
5.4 notes. You don't feel that way.
I think
Do
it
you?
works.
Do you actually feel that way?
No.
Okay.
Yes, he does.
Because I have to take those things seriously.
No, I got glue
I
on my
do.
finger.
Okay.
That's so important.
We've been talking about our new identities, the sum and difference
Oh, that's it. I'm done.
formulas. Okay, so as a review, this allows us to find exact answers of angles that aren't necessarily on our unit circle, but we can break it up as a sum or difference using angles that are on our unit circle, using these sum or difference identities to get exact answers. And it is fun if you
No.
forgot.
No, always fun. Don't remember.
Did you guys see my shirt that I wore in the Angle Olympics?
No.
Yeah. No.
What did you
It was
say?
a Nike
Just
swoosh and it
do
said,
math.
just do that.
Oh
Just
yeah,
do
do
math.
that. That's so.
I was so excited to wear it. I was like, this is going to be so great.
Oh my gosh, what?
That
You
could
guys were
100%
such
see
a
where
yesterday.
Shut
I
up.
can't believe it.
Have you
I
ever?
really want to squeeze you.
I have another math.
Where are you wearing jeans? Why wearing jeans in elementary grade?
I didn't know what was
I was so confused when someone told me in the hallway they were doing the Olympics, and I was like,
still read?
what Olympics?
All
All right.
Stay there and stay there.
I wish we would have done Kahoot again.
Okay, yes.
Again?
Still in
Oh,
that one.
We tried doing a Kahoot for 30 minutes.
That's
with
like
150 people.
I heard about
trying
it, and
to
it like it just the internet didn't work. Yeah.
We should.
Yeah.
All right, Tyson. Have you started to think about how we could break this one up yet?
No.
30
No.
and
No. Tyson ugly.
Okay, what do you
Shut
think, Max?
up, Carter.
Negative 135 and negative 30.
I'm just helping.
So negative 135 plus negative 30.
Dang.
Okay, that would work. I did negative. This is another one. I did negative 120 and negative 45.
That's the one I would have done.
That's what I'm doing.
I'll let you know that.
Okay.
Carter.
And
It doesn't matter.
120 something.
We can do this one. Let's see.
Yeah.
Let's do this one and see if we get the same answer as me. Okay, so here's my U and here's my V, my two angles, and I'm just copying the trig identity for sine sum addition is the sine of the first angle times the cosine of the second okay plus cosine of the first angle times the sine of the second. Okay. What is the sine of negative 135 degrees, Maximus? Negative root 2 over 2.
I appreciate
Remember, negative 135, we'd have to go this way on our unit circle. So it'd be in quadrant 3. All right, Max, cosine of negative 30.
root 3 over 2.
Yep, positive in quadrant 4 for cosine. Cosine of negative 135.
Negative root 2.
Sine of negative 30.
Negative
Negative 1/2. So in quadrant 4. Good.
Math.
So we end up getting negative root 6 over 2. Positive. Oh, sorry, over 4. Over 4. I was trying to add that. Positive root 2 over 4. So I would probably write this as root 2 minus root 6, or you could do negative 6 plus root 2, doesn't matter. All over 4. And that's the same answer I got when I broke it up a different way.
God, we're just so smart.
Right?
I'll be honest.
I'm gonna be honest with you, buddy.
Mm-hmm.
I feel like I could go on in life without knowing this.
Mm-hmm.
Probably.
Okay, now we're going to use the identity backwards. They're going to basically give us the expanded. They're basically going to give us the expanded identity. And we're going to rewrite this as the sine, cosine, and tangent of an angle. So looking at this one, cosine, cosine, minus sine, side. Which identity does this look like?
Cosine plus.
Cosine plus. Yep, cosine plus. Good. Where I have the cosine of an angle, cosine of the second angle, minus the sine of the angle. So you can think of this as like your U, and this is your V. So this would be the same as the cosine of pi over 7 You guys okay over there?
What are you doing?
Trying to play footsie.
That's
so
weird.
don't-
Stop it.
Okay.
Weirdos.
How's it going?
Everybody good with that?
How's life?
Yeah.
How we get from here to here?
Yes.
Kind of using the identity backwards. Okay, now let's actually add these together. Common denominators.
35.
I like it.
No.
So this is 5 pi over 35.
Plus you.
7 pi over 35.
12
pi.
So smart, dude.
12 pi over 35.
Should be in choir. Should be the music teacher.
Wrong
That would be so
career path.
bad. The only thing I sing is a quadratic formula song.
Do it, you won't.
Tangent.
I did last time when we did that. Didn't I sing it to you guys when we did that shirt one with the
I don't think so.
I think I did.
I don't remember it. You should jog my memory.
Alright, which one does this look like? Obviously there's a dead giveaway here. That's gonna be one of our tangents. Tangent sum or tangent difference?
Difference.
Difference, right? Look at the signs. So think of this as your U and this is your V. This would be the same as a tangent of 45 minus 30. This would be the same as a tangent of 15 degrees.
I understand that, but I'm confused.
Yes.
That's
Why on the denominator is there 40?
This should be
45
plus
minus?
probably. Wait,
That should just
Isn't
be
it multiplication?
it probably is. I typed these, so it's probably just my typo. Yeah, that should be times. Sorry. That's probably just a typo on me.
Messing us up.
Oh, yeah.
First time I ever made a mistake. I know it's so embarrassing.
Definitely the first time.
No, you were just making sure we were on
Thank
the
you.
toes.
Let me just make myself this note so I remember to change
Watch
that.
out for my pencil. I super glued it before I came in here.
Okay. Change that.
Thank
Thank you.
One more time.
Can I tell you this one more time?
Yeah.
Okay. So look at your identities.
Yeah.
And obviously it's gonna be one of the tangent ones.
Yeah.
So which one does this look the most like where I am subtracting in the numerator? Subtracting in the numerator is the difference one for tangent.
Yeah.
Do you see that? So that's the same as taking, and then I kind of labeled like this would be your U, this would be your V. That's the same as a tangent of 45 minus 30, which is a tangent of 15. We're kind of using the identity backwards.
I could definitely do this.
Hold on, what?
Why don't you do the stuff on the bottom?
This is still like, this is part of the whole identity. Like this is still U and V. See how like that identity on your sheet has
So like on that one,
over.
you just have to do. Alright, I think I might.
This is like the same. If you look at your identities here, I can go back to this.
Wait, why do we have an equal sign for the next one?
Like this one looked like this, right? Where I had the tangent of 45, and then I had that table. This should be times, if that confused you. So this is the same as the tangent of whatever U minus V is. So then I was like, okay, well obviously my U is at 45 degrees.
So like on the cosine one, you just.
It matched this one. Because I had the cosine of an angle times the cosine of the second angle.
I got it.
Yep, it's basically going backwards.
I got it.
Oh, these are fun.
Are they? Verifying the identity.
It's combining
Yeah.
like what we already know how to do, verifying, but now adding in our new identities.
Oh yeah.
No.
Oh no.
No.
Yeah.
Yay.
These are bad. These are bad. Okay.
Illegal.
Sorry.
I'm gonna find you.
Don't have me.
Yeah,
We
man.
would never.
You're just trying to be mean.
Yeah, we're trying to.
We're jealous. Okay.
All right.
Your favorite math teacher.
Verifying
Yeah.
steps. Which side looks more complicated?
The
The
right.
left. I can use my cosine difference identity, which is the same as the cosine of the first angle times the cosine of the second angle, and with cosine the sign flips, plus,
Why can't we just do cosine however 2 minus u equals sine?
Why can't we just do the conjunction identity?
oh yeah, we're proving the conjunction identity right now. Yeah, okay, I like it. Yes, you could, but we're proving why this identity. Okay, proving something we already know.
Yeah, exactly.
Jeez, who came up with this?
You should do a Connor's voice more often.
Co-function. I think I said confunction because you said it. I think I just echoed what you said.
Junction, what's your
Co-function.
I looked at it. I didn't realize that's what I
It's right here.
said. Hard to understand.
Co-function. All right, what's the cosine of pi over 2?
0.
0. Cosine of pi over 2 is 0. What's the sine of pi over 2? 1. So obviously we get sine of x. Okay.
This is
Dang, that is what it equals.
There's a proof for you.
I don't like proofs.
Okay.
I thought we didn't have to do that.
I think I'm gonna start calling him John.
Whoever said that lied to
Because
you.
it's easier.
Big Booty Judy never lies.
Lies.
Are you a
No, I'll say like 2 column proofs. You don't have to do it ever again.
Yeah, she only does. She does.
Guys, this is recording on YouTube. Don't embarrass me.
Embarrass you.
Please
Everyone
subscribe to
needs
the
to know
Wait, we're 2
Also,
column
sometimes
proofs
you guys
again.
embarrass me when my student teachers here. You guys are like obnoxious. I'm like this poor girl.
Yeah, I feel that.
No, I bet you
I
she
do
felt
too.
bad the
And
one
she's
time
like
I.
taking notes back there. I'm like, what are you writing? But I'm terrible and I can't control
I
anybody.
think it's a good experience
to
for
listen
her,
to high
so
school
in case she
movies.
realizes she doesn't actually
At
want to
least
do
we're
this.
not late.
I thought it was funny the day you left.
Sometimes you guys are rude to each other.
Yeah.
Why
When
doesn't
you
she
leave-
talk?
When you're sick.
Yeah,
you
I
said
did.
that.
I tried talking to her the one
Guys,
day.
stop.
We like you. Don't worry.
We don't look at her.
Like Mr. Weber's student teacher, he's hilarious. He talks to us all the time.
No,
I like
I
her.
don't know her because I blamed you.
What's the first?
Gave me a seat that one day.
Okay.
Just sits back there and doesn't speak.
I was listening to Jared, and then I heard her go.
All right. Long story short, I like your guys' energy. I feel like it's like a good engaged energy, right?
Yes.
Yeah, 100%.
Wouldn't it be so boring if I just stood up here and nobody said anything?
Yeah.
We had a class
Trust me, I
like
sat in
that.
here and it was like.
It's kind of how my geometry class is. I'm like, somebody give me something.
Yeah, I remember that. So I was in the same test.
Yeah, they're dead side.
Yeah, she cried.
He just sits up there.
Who, Judy? Yeah. Because no one talked.
Okay,
We're all afraid of her.
now this one you're like, which side's more complicated, left or right? But we're gonna work with left because we see this difference and we are in this
Zone.
unit with difference identities, right? So I have a tangent difference. All right, so I'm just copying from my identity sheet. If it helps you to write which one U and V is, you can. That's the same as the tangent of my first angle, pi over 4, minus, or is it plus?
Minus.
It's minus.
Wait, no.
It's minus on top, plus on bottom.
It's minus.
It's minus. It is minus.
Oh, this is the difference one?
See, I don't have these identities memorized. I don't expect you
It's
to. Minus
That's plus.
tangent of the second angle,
Damn, stupid.
all over 1 plus tangent of the first angle times tangent of the second angle.
I'm server.
Okay, so what is the tangent of pi over 4?
Nah.
1. That one we should know. 1
One.
minus tangent of theta all
Oh my gosh,
over
it's gonna be
1 plus 1 times tangent of theta. And there you have it, folks. That's all we're trying to prove.
1G.
Yeah.
This is
Go
impressive.
Eagles.
Go Eagles.
You.
We're golden eagles.
Actually.
So basically, we're just adding a new identity. We're adding a new identity to our repertoire of.
I didn't know you were Latina.
We're adding
I am Czechoslovakian.
another tool to our math toolbox.
Toolbox now?
Wow, isn't that so good now?
Okay,
I have this piece of paper.
let's try a couple of these. We'll finish this.
Oh, we're gonna finish this.
There's a couple like this on your homework. So you're given not the angle, but you're given the sine ratio and the cosine ratio of these two angles U and V. All right? So the sine of some angle is 5 over 13, where that angle is in between pi over 2 and pi, which is which quadrant?
Something.
Three, two.
Good
2. Pi over 2 and pi would be quadrant 2.
Yep.
Right? And then they said for V, for this other angle, the cosine of it is negative 3/5 in quadrant what? 3. All right? So we're going to draw a couple pictures here. Let's draw one for you. You could also use identities if you want, but we could easily just draw right triangles for these because they tell us what quadrant we're in here. We're in quadrant 2.
Shut up.
And then we, oh,
Ow.
Why did that remind us?
Oh.
Didn't you just
I
give
feel
a
like for
speech
you
about
guys-
us being nice?
I feel like for you guys, I need to do like little like a kindergarten like star chart. Like every
No,
time
we
you
need to
say
have,
something
no,
kind,
Can you
Jackson,
do that?
you do
Can
a
you please?
star.
No, we need to have
Every
red,
time you say
yellow,
something
and
mean, I remove
Yeah.
a star.
And you should give us stickers too.
I feel like you guys need some like positive behavior
We should
reinforcement.
have red, yellow, and green
Yeah.
cards, and so then you change it to
After
red.
Goosey, you can get your green card finally. No, send her a 10.
Let me.
What did Jackson say?
Wow.
You can finally get your green card.
Jackson.
The bad one. You get a red card.
That was a
That's a
line that did
green
not need to
card,
be
by the way.
crossed.
That's a
Let me collaborate with my second grade teacher friend this weekend and see if I can come up with some behavior systems. For
No,
my-
we just need to stick them in the corner.
No,
What
it's
Mr.
not.
Wagner
They'll take
wants
it.
a presentation.
No. Here's a good punishment. Make him sit in his actual spot.
Jackson, so many stars off your chart, you're going back to right here.
Oh.
I don't want to be next to her. No, she's staying.
Okay,
What can I say that's
let's focus. The sooner we finish this, then we can like have fun.
Okay.
All right. I know, math is so fun. So we know the sine of this in quadrant 2, the sine of this angle, and we could call it u if you want to, you don't have to call it theta. We know the sine of this angle, we're calling it u, is 5 over 13, opposite over hypotenuse, Pythagorean triple, what would this side be?
8.
12, but since we're in quadrant 2, negative 12. Okay, there's my sketch for angle u. For angle B, we know it's in quadrant 3. And we know the cosine of this angle is negative 3 over 5, which makes sense that this would be a negative 3. The hypotenuse would be 5, meaning this side would be what?
Four.
Good, negative 4 since we're in quadrant 3. Okay, so there's what we know about u and v. So when you do these problems, just draw a quick sketch. They will tell you, they'll either say in quadrant 1, both angles are in quadrant 4, it'll tell you, or it'll give you in this like inequality. So this told us quadrant 2, this told us quadrant 3. Okay, what they want us to do is find the tangent of u minus v. So I'm going to use my tangent identity. I'm just going to rejot the tangent identity down because I don't have them in front of me. So it's the tangent of u minus the tangent of v all over 1 plus the tangent of u times the tangent of v. Okay, now again, we don't know the angle. We don't know the angle, so I'm not going to like plug in an angle measure here, but I can figure out what the tangent of u is using my sketch. Right? What is the tangent? Oh, I'm going to call this one. Sorry, I keep doing thetas. That's just out of habit. I'm going to call this one v.
I hope thetas for both.
That's fine. Just maybe like label right here. So if I look at my u sketch, tangent would be 5 over negative 12. Everybody okay with that?
Yes.
Opposite over adjacent. We know tangent's negative in quadrant 2, so it makes sense that our value is negative here. Minus the tangent of angle V. So over here, yep. And is tangent positive in quadrant 3? Yeah, so it makes sense. Obviously, I have negative 4 over negative. It's going to come out to a positive 4/3. Okay, so up top I have negative 5/12 minus 4/3. We'll do that math in a second. Let's get my denominator here. 1 plus tangent of u, we already found that, negative 5/12 times the tangent of v, 4/3. Oopsie. All right, up top here, honestly, do it in your calculator, make common denominators. What do you need to do to get the right answer? It's negative 7/4. And down here, 1 plus this product, I got 4 9s.
Agreed.
So then we can times by reciprocal. Oops. We get negative 63 over 16. for that.
Solid.
Okay, good. Now, if you look at number 2, you're like, wait a minute, we don't have an identity for cotangent.
But over one.
It's just 1 over tangent.
It's just the reciprocal of tangent.
Yeah.
Now, let's say we hadn't found tangent yet. All you would do is take the reciprocal of the identity, okay? Not the reciprocal of like these separate ratios. That's different. You would do the reciprocal of the whole identity. So you do 1 plus tangent of u, tangent of v. That's a common mistake is sometimes people will just like flip this one and flip this one. Like these ratios. You can't do that. You gotta flip the entire identity. Which obviously we just did that, and that's gonna, you can mathematically see like why that works. That's just gonna flip what we get on top and bottom, so it's gonna get negative 16, 60 over 63. All right, so flip entire, or reciprocate, maybe that's a better word. Reciprocate entire identity. Not just those separate tangent ratios, because then that's gonna get some confusion when we add or subtract them. Yes, sir.
Wouldn't that first one, wouldn't it be over 5 over 9? And then there's
1 plus, isn't it 1 plus? These two is negative 4. I put
You
negative.
have 4 over 9.
Yeah, 1 plus. Doesn't this multiply to negative 5/9? Because, oh gosh, just stay in place. Because these
Oh yeah, okay, I see.
would be,
Yeah.
that'd be
He was
3.
wrong.
That'd be negative 5/9. It's okay. 1 plus negative 5/9 is 4. No, it's okay. I appreciate you saying that. Good. Okay.
I'm just glad I went.
Oh, we only have one thing left to do.
Straight line.
Okay, this is so fun. This is why math builds. We already know how to solve trig equations.
Speak for
Now
yourself.
I'm gonna throw in ones that involve the sum of difference identities. Carter loves solving.
So 2 things that I don't know how to do. Got it.
So what we did in 5.3 the last lesson, adding in some new identities. Okay, this actually, once you apply the identities, it's not as bad as you think. I look here and I see, at least everything's in terms of sign. And I see, okay, I have a sum. So I look at my identity sheet. Is there something I can do here? And obviously my eyes go to the sum and difference formulas, right? So for sine, sum, it's the sine of the first angle times the cosine of the second angle. For sine, the signs stay the same, plus cosine of the first angle times the sine of the second angle. So that's just that first piece.
You do that a plus sign.
And then we have plus
And then you do
the sine difference,
sign.
which is the same pattern, the sine of the first angle times the cosine of the second, but it's minus cosine of the first times the sine of the second, and this all equals 1. Okay, so that'd probably be something I would try first because I see an identity that can be applied.
I mean, it looks solved to me. It equals 1.
Do you guys see any simplifying we could do here? I have 1 cosine x sine pi over 3 minus.
Yeah.
Oh my god, that's
Oh
magical.
my gosh, this green marker is just. I've just had it with this green, and I don't have a black one.
That seems
Where is my
aggressive.
10? All right, give me green. Thank you.
You're welcome.
These are 0.
Yeah, they are.
2 sine x.
Now we know what the cosine of pi over 3 is, right? What is it? 1/2.
A number. That's what it is.
Plus 1/2.
And we have the same thing here. So if I rewrite it like the 1/2 in front, which is usually how you've seen it, or usually how you will see it. Right. What do you guys think 1/2 sine of x plus 1/2 sine of x is? 1 sine of x. 1 sine of x. All right, they only want solutions on the interval 0 to 2 pi here. So what's my only angle on the unit circle that gives me sine value of 1?
Pi over 2.
Pi over 2. If it asks to find all solutions, you just add that plus or minus 2 pi n. We can add that in here.
Only one left.
Also,
Then we get work done, right?
Sol stands for
Yes.
solution.
Let's roll.
this section's a little bit longer, but we'll definitely finish it. Okay, one more. Ooh!
There's back.
Tangent. Hey, so whose idea is the
Tangents and sines. Okay, let's try it out. I see a tangent sum. So using that identity, tangent of my first angle plus tangent of my second angle, all over 1 minus the product of tangent of the first angle times the tangent of the second angle. You'll do these identities so much that you'll accidentally start to memorize them.
I mean, accidentally. I already started.
Jesus. Not accident.
Okay,
You doing it on purpose?
2. Some of you guys got confused on that quiz when there was a 2. The 2 just stays out here. It's fine. All right, so for this sine sum, I have the sine of the first angle times the cosine of the second plus cosine of the first angle times the sine of the second. So that's all technically being multiplied to 2, so make sure you put that in parentheses, and apparently this equals 0.
Apparently. I think it
I
does.
don't believe it.
Okay, let's see what we can do here. What's the tangent of pi?
What's that?
Zero.
Zero.
Undefined.
No, 0.
No.
Oh, stupid.
Okay, pi
Red card again, Jackson.
Pi is -1, 0. So tangent's y over x. So it's not undefined.
Yep.
It's 0.
Yeah.
All over 1 minus tangent of x times 0. Okay, we'll clean that up in a little bit. Let's work with the blue one. What's the cosine of pi? -1. What's the sine of pi? 0. Thank you, Natalie. All right, so here obviously you have like plus. Oh, green word. Just want something else that gives me a different color to cancel things out. Let's do pink. Okay, so obviously plus nothing is 0, plus nothing is 0. Okay, I don't like that. So I just get tangent of x over 1, which is just tangent of x. Everybody okay with that?
Yes.
Yep.
Plus nothing
Sure,
minus nothing,
sure,
tangent
yes.
over 1.
Uh-huh.
All right, bless you. That's obviously 0, cosine of x times 0.
How come you cancel next to a plus sign?
That doesn't make
Didn't they just kill a cat?
No, sorry, I'm not canceling this. I'm just saying plus nothing like it's gone.
Oh.
I'm not like canceling them. Okay, maybe that's confusing. Good.
Oh, it's a
catch.
dashed line. That's why it's
Yeah.
like that.
I'm just saying plus nothing would just give me tangent. So like you could even do this. Plus nothing. That times 0 would give me this. I'm just looking at tangent. That's what I was saying. Yep, sorry. All right.
You need to work kill the cats. Like, whatever.
So same thing here. I'm just saying cosine of 0 is 0. So this ends up being -2 sine of x. Okay, so this actually obviously looks like a lot simpler, but I have issues here. I have tangents and I have sines.
Sine's a cosine.
So let's try and change tangent. I like that idea. Tangent is sine over cosine. So now I'm kind of using identities to see if I could somehow get these to be the same trig function. You can think of the sine of x as over 1. So what do you guys think we need to do here?
Multiply by cosine.
Common denominators. Common denominators, my friends. So, yes, we would multiply this one by cosine, top and bottom. This is a fun little problem.
Is it? Is it though?
A cute little problem. Yeah, I like it. Sine of x over cosine of x minus 2 sine x cosine x over cosine x, and now I can add these together. See, thank you. Subtract these together. Because it was times a -1 here. Yep. All over
Whatever.
my common denominator. Ooh, Brianna said factor the top. We will factor the top. What can I do with this cosine of x? Don't say cancel. You can't cancel those. because this one doesn't have a cosine
Multiply it over the other
x.
side.
Multiply it to the other side. Good, Connor. Multiply both sides by a cosine. Where's my...
I'm okay to hurt it and then kill some cats.
Okay, good, though. We can't cancel those. We can multiply both sides by the cosine of x, as long as we do it to both sides. Okay? And Brianna said factor. What can we factor out? Good. So I'll do that in my next step here. We're doing good. So I get 1 minus 2 cosine x. All right. ZPP.
These signs are
Super big.
really messy.
Sine of x could be 0. We'll solve that in a minute. 1 minus 2 cosine of x could be 0. We'll solve that in another minute.
Keep putting addition in.
These ones are still just 0 to 2 pi. So what's the only, I should say only, there's 2. What are the 2 angles on the unit circle where sine is 0?
Pi over 2.
No, sine is 1 there.
Oh,
Pi,
0
pi.
pi.
0 and pi. And technically we call that one 0 and not 2 pi based upon like the directions that it has to be in this interval, including 0 and not 2 pi. Okay? This one, add over the 2 cosine x, divide by 2. I want to know where the cosine of x is.
2 pi over
Positive
3
1
or 4
half.
pi over 3.
Positive 1 half.
Oh, positive.
Yeah.
Pi over 3, 5 pi over 3.
Good. There's your solutions. Wasn't that fun?
No, because I
Yes.
was able to do that on my own.
Well, now that you've seen one,
My proximal.
you have an example of that.
proximal-
Bless you.
Thank you.
All right, you did finish the lesson.
Psychology.
What's the next one?
Jackson got.
What's the next one?